Division of algebraic expressions involving exponents. So let's start with a simple example. We have x to the fifth divided by x to the third. Now, when we have a division question like this, we could also write it as a fraction. So in this example, I'm going to do that. Let's change this to x to the fifth over x cubed. Now, an exponent of 5 means x times x times x times x times x 5 times. So I'm going to write that. I'm going to use the dots so we don't get that confused with the x's. And an exponent of 3 means x times x 3 times. Now we know that x over x is the same thing as 1, right? So therefore we can simplify or cancel these x's. So I can cancel the first x on the top and the bottom because x divided by x means 1. Then I can cancel again, and then I can cancel again. And now I have just 2 x's left over. So x to the fifth divided by x to the third is going to be equal to x squared. Now, there is another way that we could arrive at this exact same answer. So let me get rid of this. We could say, instead of going through all of that, that x to the fifth divided by x to the third is the same thing as saying x to the 5 minus 3, which is x squared. Now we're going to look at another example in just a second, but first, here are some steps to dividing algebraic expressions. First, if there are numerical coefficients, divide the numbers. Second, divide the letters, and remember that exponents can only be subtracted if the base is the same. So let's say I have 15y to the ninth divided by 3y to the sixth. So here I do have numerical coefficients, so I'm going to divide those first. 15 divided by 3 is 5. Now I'm going to look at the letters, and I can see that the bases are the same. They're both y. So that means the same as that y to the ninth divided by y to the sixth means the same as y to the 9 minus 6. So my final answer is 5y to the third.